in your syllabus. Okay. Is the board little clear? Hmm? Okay. And those who have already attended the session on Saturday would recapitulate their notes with the discussion about rubbers. There I was like talking that the resins which are having the properties of elasticity are called rubbers. And this property of elasticity is due to the presence of a very coiled structure of the polymeric chain. Okay. The coiled structure is again due to the presence of huge hydrocarbons having unsaturation in them. Now, the elasticity property is because when the pressure or heat is applied on the polymeric chain, the chain undergoes elongation. That is, when you are applying pressure, this chain undergoes elongation due to uncoiling of the polymer. Okay. And the area which has underwent elongation will be crystalline in nature as compared to the rest part of the coiled chain. The coiled structure is generally amorphous in nature. Okay. And when stress is released, what would happen? Again, recoiling of the polymer chain takes place. And hence the property of elasticity. Now, these are rubbers and they are available naturally, and a large number of non-synthetic rubbers are, of course, in utilization today. So, the natural rubber was the main first compound which was isolated from the latex of the trees. Okay. Cis is the common one, but trans are also present. Okay. And what you realize is that this latex, because of its gummy properties, was made into a ball, and actually it used to be a plain object for the mini. Okay. And when they analyzed the structure of this natural rubber, they found that natural rubber has a monomer called isoprene. Isoprene is nothing but 2-methyl-1,3-butadiene, which undergoes self-polymerization and will give this rubber, which is present in the latex of many plants, huge trees in fact. Okay, so how the polymerization of this isoprene would take place? Okay, it will be a 1,4 addition. What is 1,4 addition? And I think I've given you the structure on the other day. Okay, so what you have realized is that there's a double bond between first and third carbon, second carbon, third and fourth carbon, and a methyl group on the second carbon. During the polymerization, the rearrangement of pi bond takes place with a new found double bond between second and third carbons, and the first and fourth carbons are open for polymerization. Because 1 and 4 compounds are going, carbons are undergoing polymerization, it is called as a 1,4 addition reaction. After the structural elucidation of the isoprene, then the large chemistry of making synthetic rubbers was taken up. They are generally called as elastomers. I've already told you, during the Second World War time, co-polymerization of more than one butadienes was done, and this large chemistry of rubbers has come into existence. Okay, so what you have in your syllabus is about the Buna S rubber, which is a co-polymerization product of 1,3-butadiene and styrene. You have also butyl rubber in the syllabus, which is a copolymer of isobutene and isoprene. Okay, and silicone rubbers, are actually copolymers of methyl silicones. Okay, methyl silicones, I'll give the structure, which are halo compounds. But what I can tell you is these are very fond actor compounds because of their strength, because of OSIO bonds in their structure alternately. This we'll discuss right now. Okay, but then, well, again, once to the recapitulation. What is called vulcanization? What is vulcanization? Roll number 120. Absent. Why they are busy otherwise? 19. Roll number 119.
Yes, ma'am.
Good morning.
Good morning, ma'am.
Yeah, tell me. Why vulcanization of rubber is done?
Heating of
Then a
sulfur,
grid
ma'am.
view. Even a grid view వచ్చింది. నేను grid view తీసేయాలంటారా?
What, ma'am? Not understood, ma'am.
I've got the screen in a grid view. How to take away this grid mode? Okay. Why? What happened? Why you are not able to tell me? Why vulcanization of rubber? Roll number 118. Vulcanization అంటే ఏంటి? 118 is absent. 117.
Yes, ma'am. Hardening the rubber.
చెప్పు నాన్న. ఏంటి? వాట్ ఈస్ వల్కనైజేషన్? అమ్మా బాబోయ్, మీరు ఎందుకు నా బోర్
Rubber which
కొడుతుందా?
is eating with sulfur, ma'am. Rubber which is eating with
Rubber
sulfur,
is
ma'am.
heated in sulfur. Why? Why?
Cross-linking, ma'am. For long
ఎంత?
rubbers molecule, ma'am.
ఏంటి?
Which
What
improves
it is?
elasticity, tensile strength, ma'am. Yeah,
Why?
waiting.
How? Okay. Anyone in the class who can explain what it means by vulcanization of rubber? Hello, good morning. Okay, roll number 119.
Yes, ma'am.
You didn't answer me. Correct?
Just now I told, ma'am, which is heated with sulfur. Up to that I know, ma'am.
Okay. Then sing me a song. Huh? Roll number 118 is present.
Yes, ma'am.
Yeah. Tell me why what is happening during vulcanization, boy?
Heated with sulfur, ma'am.
అదే
The
heated with
process
sulfur తర్వాత ఏంటి?
by this
Sulfur.
process we get the cross linkages.
That's the cross. Correct. To get the cross linking. So what is vulcanization? Heating rubber with sulfur or sulfur based compounds for increasing the physical, chemical and mechanical properties due to formation of sulfur cross-linked bonds. Due to the formation of sulfur cross-linked bonds. The pi bonds between the chains are broken to form sigma bonds with sulfur, which increase the mechanical and physical and chemical properties of sulfur. Vulcanization. Okay. Now I'll get back to the discussion. Are you able to see the board? Okay.
Yes,
So first one, Buna S rubber. Buna S rubber. Okay. It is also called styrene rubber, also called styrene rubber or GRS rubber. GRS rubber.
I'm adjust the camera, ma'am. Not visible.
Okay. That's
Yes,
rubber.
ma'am.
Okay. So what's the first point? What's the first point? Did I speak to you about this rubber? What it is a copolymer. What it means by a copolymer? It is a copolymer of, it is a copolymer of 1,3-butadiene, 1,3-butadiene, 75 parts by weight, 75 parts by weight, and styrene 25 parts by weight. 25 parts by weight. It is a copolymer of 1,3-butadiene and styrene. Okay. It is obtained by copolymerization. It is obtained by copolymerization. Copolymerization process using cumene peroxide as initiator. Cumene peroxide as initiator. Cumene peroxide as initiator. Now, what's going to be the functionality of butadiene and styrene? Roll number 116. 116 is absent. 115. Yeah, good morning. Now tell me, what is the functionality of butadiene and styrene? What it means by functionality, boy? Yes. Okay. What would be the functionality of butadiene? Two. Anyone in the class? Two. Both the polymer monomers it is two. Now, can you tell me what it means by copolymerization? What it means by copolymerization? మీరు చెప్పగలరమ్మా. You should first, if someone asks you a question, you should not be in agitated mode. First thing. Second thing, you should know how to apply whatever you know. That's the reason why I keep asking. Actually, it's a very laborious way of teaching. If I just jot down something on the board and explain you quickly, that will do the job for you and me as well. But that's not what is to be delivered. In fact, there's a I'll give you the entire notes today, and you'll study and reproduce. But it is not that just mugging up or learning subject before the exam and just putting it on the paper. No, that's not the deal. The learning is a very cumulative process. You learn so many things, actually. So that's the main reason why a good learner is always young. That's the idea. Okay. Em cheppanu. How many steps addition polymerization has? Huh? How many steps addition polymerization has? 3. What are they? What are they? Next,
Chain
roll number
initiation.
114. 114 is absent. 113. 12. 11. Okay, boy, you were telling something? Who was answering the question?
Chain initiation, propagation, termination.
Chain initiation, chain propagation, and chain termination. So, if the initiators are peroxides, then what type of polymerization takes place? What type of addition polymerization takes place if the initiators are peroxides?
Chain initiation.
Chain initiation lo peroxides unte elanti polymerization avutundi?
Free radicals.
Free radical. Ante. Sare. Now I am saying it is co-polymerization. So what is co-polymerization? It is addition polymerization between more than one monomers to give a copolymer. Okay. So what you'll say, what is copolymerization? It is addition polymerization with more than one monomer is called as copolymerization. Again, it has 3 steps: initiation, propagation, and termination. And generally, while making Buna S rubber, cumene peroxide is the initiator, and hence the polymerization is free radical addition polymerization. That's the idea. Okay. Now, so what's the preparation method? I'll write 1,3-butadiene. 1,3-butadiene. Can you, if you are able to write it, please do go ahead. And what type of addition takes place? Em addition avutundi? Em type of addition avutundi? Chandra.
Free radical.
Free radical addition polymerization.
What it means by 1,4 addition? What it means by 1,4 addition? Cumene peroxide. Initiator. Are you able to see the board? Huh? Now, what's the structure of butadiene? 1, 2, 3, 4. The 2 methyl end level. So double bond on 1 ends, 1, 2, 3, 4 carbons. Diene ante rendu double bonds. So one double bond is between first carbon and second carbon, and the second double bond is between third and fourth carbons. Is the structure legible to you all? Anpistonda? Yes or no?
Yes, ma'am.
Ma'am.
Sorry. So that's the structure of butadiene. What's the structure of styrene? Benzene ring, CH double bond CH2 is styrene. Okay. So if M molecules of this is combining with N molecules, it is 75 parts. This is 25 parts. So stoichiometry is not in the 1:1 ratio. So I have specified that. 3:1 ratio, Nadi. Yeah. So what could be the polymer? Structure of the polymer. Now what I'd like to do, because I want to present it clearly, I'm writing it elsewhere. But you can put an arrow and start writing the polymer structure. So what would happen? 1,4 addition here. That means the double bond now has to be placed between second and third carbons. The first and fourth carbon should be involved in polymerization. So the now new structure would be CH2. It has started polymerizing at this end. Okay, CH, double bond CH, CH2. Okay, now first carbon and fourth carbon are now have started polymerization, because first and fourth carbons are polymerizing. I'll say 1,4 addition reaction. 1,4 addition reaction. 1,4 free radical addition is more appropriate. Okay. Now this will form bond with what? With what here? See, this is styrene structure, CH double bond CH2. Now this will break the pi bond and it will start combining. It will combine with CH2, single
Ma'am,
bond.
not visible, ma'am.
హాయిగా ఉంది నాట్ విజిబుల్ అంటే. ఇప్పుడు నేను ఇంతసేపు చెప్పింది నాట్ విజిబుల్. Did you understand what is 1,4 addition? Why did I say it as 1,4 addition? First, the double bond between 1, 2 and 3, 4 has broken. A new double bond between second and third carbons have come in. The first and fourth carbon are now participating in the polymerization and the chain is elongating. Because first and fourth carbons are polymerizing, the addition is called as 1,4 addition. Because cumin peroxide is the initiator, you can also write it as 1,4 free radical addition reaction, and it's a co-polymerization. Now I'm writing the polymer, where I'm writing now this butadiene is combining with styrene. Now how to write this styrene? I am writing. Please check. The styrene can get attached at this carbon or this carbon, any of these carbons. But I am writing it with CH2, single bond, CH. I am writing this benzene structure as PH, and that is open. Now how many molecules of styrene? I have written N here. Okay, so I'll write it as N here, or N minus 1 exactly. How many molecules of butadiene? M. So this is the polymer, Buna S rubber. That's a polymer, Buna S rubber. You get the point. How to write the structure of the polymer. This is a found after question for most of the examiners in the mid and final exams. Write the monomer and structure of the polymer of the following compounds. I hope you got it. Easy. Does anyone has a doubt? If you want, I'll explain. Or I just want to move to the next point. I'll move to the next point. Okay. No one has a doubt? Have you become confident writing that structure?
Ma'am, there are 3 carbons in styrene structure.
Enana? Okay, sorry. ఇక్కడ వేయాలి కదా. Thank you. బట్ మా వాళ్ళు ఏంటి మౌనవ్రతం వాళ్ళ? Sorry, that's a structure. Good, thank you. I hope అందరు అది హర్డ్ అనిపించుకోకూడదు. చూసింది రాసేసాం, అమ్మాయి అయిపోయింది, మ్యాథ్స్ పీరియడ్ అయిపోయింది, ఇప్పుడు మండే మార్నింగ్ ఫ్రెష్ మ్యాథ్స్ పీరియడ్ అయిపోయింది, మ్యాథ్స్ కొన్ని ప్రాబ్లమ్స్ చేసేసా, ఓకే 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 కెమిస్ట్రీ పీరియడ్ అయిపోయింది, ఆ లెక్చర్ నోట్స్ అంతా ఉంది. You're not stenographers. That it is not a transfer of information from textbook to the board by teacher and from board of the class to the notes of yours. If you do it, your notes will be fat like me, but your knowledge is lean like you. Terrible. Get back. Okay? So what's the beauty of this rubber? It represents many of the properties are very near to that of the natural rubber and finds umpteen applications. It can be pretty much vulcanized, and the vulcanized products are having very good industrial applications, very much resistant to atmospheric conditions, strong, very resilient compounds can be made, and this actually is the best replacement for the natural rubber in many cases. And it has very good abrasion resistance. Abrasion resistance ante wear and tear due to application of heavy loads or stress. So it has very good abrasion resistance, very good tensility it has, and also it has good load bearing capability. Okay, the vulcanized rubber actually finds very good applications. Mainly it is used in making tires. Okay, apart from that they'll do gaskets, shoe soles like that. And it's also used in the footwear industry equally, replacing the natural rubber. Okay, and hence is the discussion. Right, properties. First one, resembles natural rubber, and contains wide applications replacing it. Okay. Second point, can be vulcanized. Okay. Next, high abrasion resistance, good tensility, and load bearing capability. Good load bearing capability. Okay, fourth point. Good resistance to environmental attack. Fifth point, but readily oxidized by ozone. In in brackets even tracer amounts. And the next point is, and swells in oils. Swells in oils. Swells in oils. Attacked by solvents. Attacked by solvents. Attacked by solvents. Fine. All right. Applications. Applications used for making motor tires. Making motor tires. Making motor tires. Second one, shoe soles, gaskets. Motor tires, shoe soles, gaskets. Gaskets. Cable insulations. Gaskets. Cable insulations, third one. Cable insulations. That means it is electrically resistant. Cable insulations. Adhesives. Fourth one, tank linings. Tank linings. Floor tiles, etc. Floor tiles, etc. Floor tiles, etc. Okay, next. Butyl rubber. Done. The next one is second one. Butyl rubber. Butyl rubber. GRI rubber. GRI rubber. Tell me, what's the first point? What is the first point? Hello.
It is a copolymer of
It is a copolymer of
isobutene and isoprene.
Isobutene. How many parts? 95 parts. Okay. 95 to 98 parts. And isoprene in small amounts, 1 to 5% actually. Okay. Again, it is obtained by co-polymerization by addition method, generally using peroxides as the initiator. Okay. And what is the functionality of both the monomers, isoprene and butyl isobutene? What is the functionality of? I'll just get back. But write down these two. Stupid. తిట్టే కోపం తిట్టకపోతే నిద్ర. సుత్తి లెక్చర్ అంటే ఏ లెక్చర్ బాగుందని ఏది చెప్పినా అదే పని. రండి. Copolymer of isobutene, let's say 95 to 98%, and isoprene. Actually 5 to 1%. Then it goes 99%. Okay. It's a copolymer of isobutene and isoprene. Isoprene, first point. Copolymerization. Copolymerization is done in the presence of peroxides and both the monomers are bifunctional. How many binding sites? Bifunctional means 2 binding sites. Okay. Now, what will write here? Preparation. Isobutene plus isoprene peroxides like benzoyl peroxide, acetyl peroxides are used to give butyl rubber. Peroxides are initiators. Here small proportion. So hope you remember. Butene means how many carbons? Butene means how many carbons?
4.
4.
4. Isobutene means how many double bonds?
1 double bond.
1 double bond. Good. Ade diene ante
2.
2. అర్థమైందా? సో బ్యూటీన్ అంటే సింగిల్ డబుల్ బాండ్. బ్యూటాడైన్ అంటే 2 double bonds. ఐసో స్ట్రక్చర్ అంటే ఏంటి? ఇట్స్ ఎల్ షేప్డ్ స్ట్రక్చర్. సో 1 2 3 isobutene means iso means always L. Okay, 1 2 3 4. That is actually, if you take the alkane of it, it is isopropyl structure or 2-methyl propane is the structure. Now 1 double bond. Okay, CH3, CH3, CH2. You understand? CH3, CH3, enduku carbon 2 plus 2 4. Carbon 2 plus 2 4. Here because they are bonded by single bonds, it is CH3. So that's the structure of isobutene. Functionality is 2. That is reacting with isoprene. What is the chemical name of isoprene? What is the chemical name of isoprene?
2-methyl 1,3
butadiene.
2-methyl 1,3-butadiene. What type of addition? What type of addition?
1,4 addition.
1,4 addition. Now can you write the polymer? Write it. Here you write M. Here you write N and write the structure of polymer. What is the functionality of isoprene?
2.
అందరూ ఆన్ చేసి వెళ్ళిపోయినట్టున్నారు. అటెండెన్స్ తీసేసుకుంటే బెటర్ ఏమో. అందరూ వదిలేయచ్చు హాయిగా క్లాస్. లేదా స్ట్రెంగ్త్ 50 అయిపోతుంది సడన్ గా. Write the structure of the polymer. Okay. Now I'll write the structure of the polymer. Please check. Once if you get this, then you're done. You can write the structure confidently in your exam. Okay. So isobutene, CH3, CH3, and a double bond breaks. Okay. So double bond, CH2. Okay. Are you able to see the board? Are you able to see the board?
Yes, ma'am.
This is M times. This is isobutene or butylene. Empty 2-methyl 1,3-butadiene. So CH2, CH3, double bond CH, CH2 taken N times. This is the structure of isoprene. And this is the polymer, butyl rubber. This is the structure of butyl rubber. Okay. Now, right. Properties. Properties. I'll finish in 2 minutes. This one. Very low permeability to air and gases. Very important property of this compound is properties. Very low permeability to air and gases. It's a very important property. And the second property is not attacked by ozone. Not attacked by ozone. Ozone is another important property of this rubber. Next. Next. Not attacked by acids or solvents. Not attacked by acids or solvents, but soluble in hydrocarbon compounds. But soluble in hydrocarbons. But soluble in hydrocarbons. Carbon solvents are that. But soluble in hydrocarbon solvents. Next. Good electrical resistance. Good electrical resistance. Good electrical resistance and high abrasion resistance, good electrical and abrasion resistance. Abrasion resistance. Next. Can be vulcanized but to a less extent. Can be vulcanized but to a less extent. Can be vulcanized but to a less extent. Okay, next. Properties అయిపోయింది కదా, applications or uses. Uses. Automobile industry. Automobile industry. For making motor tires. For making motor tires. Tubes. Tires, tubes, and other parts. And other parts. Usually that's the main application. And how much vulcanization is done? I'd say so 1 to 3% vulcanization is generally done in this case. Eppudu tires ki vulcanization will not exceed more than 3%. Tank linings antam kada, ante pharmacy industries lo, chemical industry, drug manufacturing, medicine manufacturing industries lo, what they'll do, they want to store things, chemicals particularly which are reactive. So there the structure has to be hard. Even our batteries and all, the rubber we are using is a hard rubber. It is called as ebonite rubber with the sulfur exceeding to 30 to 32%. Beyond 32%, they will not add. It becomes again brittle and will break just like that. The maximum allowed sulfur percentage should be 30 to 32%. And if that is the amount that is present, then it is called ebonite rubber and very hard rubber. It is hard, very unreactive, and little more brittle. It goes to the brittle direction. But when I'm talking about the automobile industry, the sulfur percentage never exceeds 3%. And carbon black is a filler generally in this case. This is the point which is interesting for us as far as commercial aspect is concerned. Okay, so that's the one. Next, making conveyor belts. Making conveyor belts in food processing industry. In food processing industry. Hope you know, it's a frequent thing that chips making and all. Then what will happen as soon as that pouch is there, chips will fall into it. The belt keeps moving. Everything is automated. Required amount of chips will fall. Then the conveyor belt keeps moving, followed by the sealing. So these are the conveyor belts exclusively used in food industry. That's the main application again. Next, high voltage insulating wires and cables. Making high voltage insulating wires. Insulating wires and cables is the cables. Is the next application for this. Okay, and I shall go to the last one, that is silicone rubbers. Silicone rubbers. Silicone rubbers. Right. These are rubbers obtained by, this is little important, as lot of commercial or industrial engineering application. These are obtained by polymerization of high molecular weight obtained by polymerization of high molecular weight dimethyl silicone polymers. Dimethyl silicone polymers. Dimethyl silicone polymers. Silicone polymers. Brackets, they are linear. With fillers like finely divided SiO2, with fillers like finely divided SiO2 and peroxide containing curing agents. Okay, please first write this, then I'll explain everything slowly and very clearly. Now, just listen to me and don't write anything in the book. This is the first point in your notes. But now what I am doing, I am explaining you the concept. Now, how many of you remember about the Grignard's reagent? What is Grignard reagent?
RMGX.
Okay, it is a source of what ions? C minus ions. Grignard's reagent lo, Jayant, please lay. Okay, roll number 90. So, RMGX. So, Grignard's reagent characteristic enti RMGX, where this R is an alkyl group. Now I'll take methyl here. So methyl magnesium halide. This is some Cl. Always this is positively charged and this is negatively charged. Okay. So the first point. So Grignard reagent is always a source of carbene ions. Okay. Now this is made to react with a compound called SiCl4, silicon tetrachloride. Then it will quickly form a compound like this: Si, Cl, 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 CH3 plus MgXCl. Then I'll add one more molecule. Okay, Then when I add one more molecule, one more chlorine is replaced by CH3. Okay. Now, I'll ask you a question. Now, what will happen if I keep on adding one more Grignard reagent to this? The Cls are replaced by CH3 groups. Okay, but I have stopped my reaction here. Okay, so what I got, I took two RMGX, okay, that is methyl magnesium halide, and I have made this compound. I've got this. Okay, now what this is called, dimethyl dichlorosilane is the name of this compound. Dimethyl dichlorosilane is the name of this compound. Now, what could be the functionality of this monomer? If I use this as my monomer, what is the functionality? Please tell me. Quick, quick, please. Ramachandra, what's the functionality of this? Please tell me. Hope you are listening. Just don't sit in the class for attendance. Bore kottundi, gear kottunani cheppadu. Malla Irish kids don't know what you want, but you always feel bored. I don't know why. Enti dan functionality. What is functionality?
Or ma'am?
What is? Ende? Will you sing me a song? Roll number 119. Huh?
No, ma'am. I think 4, ma'am.
I think enduku. It is fact. Why do you think it has 4?
Bonding sites are 4, ma'am. Bonding sites.
Bonding sites 4 and nana. Akkada chudu, see the molecule clearly. Dichloro dimethyl silane. Girls, are you taking a nap today? No one is answering me. That's pretty bad. That you're not catching up. That's not the style of any EC student. I bet on it. This should not be your energy levels. Why? Not apt. CSE EC class lo వెళ్ళి కూర్చుంటే టకటక ఏం పనికిరాదు. ఏదో కంప్యూటర్ లో అడ్వాన్స్డ్ కంప్యూటింగ్ మెథడ్స్ వచ్చేస్తే మీరేమో టైప్ రైటర్ మోడ్ లో ఉంటే ఎలా? ఎన్ని బైండింగ్ సైట్స్ ప్రతిసారి సిలికాన్ మీద క్లోరిన్స్ రీప్లేస్ అయ్యి మిథైల్ గ్రూప్స్ యాడ్ అయ్యాయి. ఇక్కడ ఇంకా 2 క్లోరిన్ గ్రూప్స్ ఉన్నాయి. సో ఎన్ని బైండింగ్ సైట్స్ దీని మీద, సిలికాన్ మీద? ఎన్ని బైండింగ్ సైట్స్, ఎన్ని రీప్లేసబుల్ క్లోరిన్స్ ఉన్నాయి?
2, ma'am.
2. సో దాని ఫంక్షనాలిటీ ఏంటి? 2. ఒకవేళ 3 క్లోరిన్స్ ఉంటే దాని ఫంక్షనాలిటీ ఏంటి? 3. Catch up. That's how you need to study what you are doing. This is how it is, right or wrong. That's what I was like trying to tell you. Right or wrong, why don't you answer the question instead of sitting like a very inert person? Just answer, and you can answer. No, why want 119? Why did you feel that it is 4? It's 2. Okay, now this is the prefix to what we are writing right now. But then silicon rubber has what groups? SiO groups, where silicon and oxygen atoms are alternating. So what I'm going to do is I am going to hydrolyze this compound. Okay, I'll hydrolyze this compound in such a way that there are 2 OH groups on this Si. Okay, so that's the next one. So what will happen? Actually, it could be a monomethyl or dimethyl silicones, okay, that are participating in polymerization. Okay, if it is dimethyl compounds, then I'll say hydrolysis. Hydrolysis, what will happen? These Cl groups will go away and OH will start adding minus HCl. What will happen? Si, CH3, CH3, OH and OH are formed. Dimethyl dihydroxysilane is the name. Now, presence of two OH groups on the same silicon makes it very unstable. In fact, there will be removal of water and formation of double bonds. Now, things doesn't stop here. So, it is very unstable. And it will quickly react to form SiO, CH3, CH3. Another molecule also would condense to form a polymer called silicone rubber. Okay, that's the exact one. So, what you'll write? What you'll write? This is silicone rubber. Silicone rubber. Why? Right? So, this write this as preparation. Preparation, right? Dimethyl, this is what you have written. Dimethyl silicone polymers, which are these are linear polymers actually. Dimethyl dichlorosilane will be hydrolyzed to form a dihydroxydimethylsilane, which undergoes polymerization to form silicone rubber. Which undergoes polymerization to form silicone rubber. Right here. Functionality 2. Functionality is equal to 2. Okay, next. Did you write this? I hope you have written this. Next. Write that as case 1. Right, case 2. Case 2. If monomethyl, my God, 2 minutes more. Which is the next period?
PPS, ma'am.
PPS. Okay. If monomethyl trisilicone chloride is the monomer, a cross-linked silicone rubber is obtained. Tomorrow I shall continue in the second hour again tomorrow. Kada? Is obtained. Okay, I'll quickly take the attendance. Hold on. Okay. Same. Hope by Wednesday, I want to hope I can finish some good syllabus tomorrow and conclude polymers topic, in fact, and start with batteries on Wednesday. Thursday, there won't be a class, and that's it. Good day to all of you. Just as soon as you give me the attendance, you can leave. Okay. And I shall quickly answer the attendance, and just you can leave and join PPS class. Okay. 61.
Present, ma'am.